Hello everyone. Today we are going to look at finding the nth roots of a number, and this is going to be problem type 1. So in short, in this lecture and the next one, we are going to look at problem of solving an equation like this. X to power of n is equal to, right hand side is given, r times cosine of theta plus I sine of theta. We want to find x. A recipe for x is given, straightforward enough to apply it. But first, let me go ahead and explain and try to show you that you could have guessed this formula. It might look a little bit intimidating at the first sight, but actually very simple one. So let me start with a very simple case and build it gradually from there. Suppose you were to solve x squared equal to say 9. Well, what are the solutions of this? You say, well, let's bring everything to one side, factor, and then get two roots. X is equal to 3 uh, or minus 3. Okay, so we are starting with very simple problem. Gradually, we are going to build up to the full case. Let's go ahead and graph the solution that we have. What does it look like? So, well, everything is sitting on the real number line. 3 to the right, 3 to the left. Suppose you want to go from one to the other. So this is 3, this is minus 3. Imagine that you go on a circle by 180 degrees and you get to the other one. The angle here is a sense of rotation to it. It's going to tell us how to go from one root to the other ones. Let's make the problem more interesting. Suppose I ask you to solve x cubed equal to 8. Obviously, you recognize this problem from college algebra. At that point, you would have said, well, the solution just x equal to 2. But what we are going to insist on is that each of these equations has as many roots as this exponent in it, that there are 3 roots. Well, of course, one of them is 2. Well, what are the other 2? So let's go ahead and do this from point of view of college algebra. So what would we have done over there? So equation, I bring everything to one side, and since 2 is a root, I know that x minus 2 is a factor. But do you remember what was the other factor? Okay, if you remember your college algebra well, you will be able to say what the other factor is, how to factor the difference of two cubes. But if you have forgotten it, that's okay. Let me go ahead and help you by doing a so-called long division. You remember the long division there? So x cubed minus 8 divided by x minus 2. So I divide x cubed by x, and that gives me x squared. Take x squared, multiply by that. I get x cubed minus 2x squared. Subtract this from that one. When I subtract it, x cubes cancel, and I'll get 2x squared minus 8 left. Now I take 2x squared divided by x, I'll get 2x. Multiply back with this thing, I'll get 2x squared minus 4x. Again, subtract this from that, and I'll get 4x minus 8. Take this, divide by x, I get 4. If I multiply back, I get 4x minus 8, and remainder being 0. Tells us we are correct in our assumption that x minus 2 is a factor. In this process, we found out the other factor. So, okay, so if you already knew how to get that other factor, very good for you. And if not, here is the other factor. So x squared minus 2x, plus 2x plus 4. So factoring this is going to give us that. Well, how do you solve that equation? You say either x minus 2 equal to 0, which takes us back to our very first guess that x equal to 2 is a root, or the other factor has to be 0, which is x squared plus 2x plus 4. Okay, surely you remember your quadratic formula, minus b plus or minus square root of b squared minus 4ac divided by 2a minus b minus 2 plus or minus b squared 2 squared minus 4 times the first and last, so 1 times 4 divided by twice the first number 2, so x is equal to minus 2 plus or minus 2 minus 16 is minus 12, excuse me, 4 minus 16 minus 12 divided by 2. I can simplify this a bit. Minus 2 plus or minus, write 12 as 4 times 3. 4 comes out as 2. And square root of minus 3 divided by 2. Factor the 2 and divide. So get x is equal to minus 1 plus or minus. And write this as we said, radical 3i. So we have three roots, x equal to 2 and these. So in these problems, when you want to write down the solution, if that was the equation that was given to you, you write 2 comma minus 1 plus radical 3i and comma minus 1 minus radical 3i. Okay, now suppose I ask you that you go ahead and graph these 3 points on the complex plane. Where are they? Well, first one is easy. First one, location 2. Let me maybe denote them in red color. This is 2. Minus 1 plus radical 3i. Minus 1 and radical 3 somewhere here. Minus 1 plus radical 3i. And minus 1 minus radical 3i. So minus 1 minus radical 3i, somewhere down here. Minus 1 minus radical 3i. Now look at these 3 points. What do they look like to you? If you set an equilateral to vertices of equilateral triangle, you're right that the roots that we found are vertices of an equilateral triangle. Let's make sure for ourselves that this is the case. At what angle is this thing sitting? And what is the radius? We have seen this before. Minus 1 plus radical 3. If I were to ask what's the r of it, you say minus 1 squared and radical 3 squared. That's r squared. That becomes 4. That means r is equal to 2. That is, the distance from the origin here and here are the same. At what angle is it? This angle, well, tangent of that angle is going to be b over a. That's going to be radical 3 over minus 1, or just minus radical 3. What angle is that? Well, that's 120 degrees. Is that right? You can likewise find out that this one also 2 points away, and this angle is 240 degrees. And of course this is, you can say, at angle 0 if you wish. So the 3 answers that we get, one is at 2, and then take this thing and go travel on a circle. Take this, turn it 120 degrees, and turn it again another 120 degrees. If you wish to turn it again, you come back where you were. That's what this theorem says, that when you want to find the root of an equation like this, first of all, whatever number you have, take a radius of that and raise it to power of 1 over n. So that's like from 8 we got a 2. By taking cube root, that is what is involved there. Then we find one point. That is what the theta over n means here. And then we take turns, rotate that by 360 degrees over n. That is because these vertices form the these solutions form the vertices of a regular polygon with n sides, and n is the exponent in your equation. The higher that exponent is in your equation, the more points, the more roots you are going to find, and the more they are going to resemble a circle. That is the idea that is involved here. Let's try it one more time before we go to actual problems here. Suppose I have x suppose I have x to power of 4 is equal to 16. Well, I can write this as x to power of 4 minus 16 equal to 0. I can factor it as x squared minus 4 times x squared plus 4 equal to 0. So I have two roots, two equations, either this one or this one. That one we just saw a moment ago. That's just like this quadratic we did with 9. This is with 4, so no problem there. And I get x is equal to 2 and minus 2. How about this one? This one tells me x squared is equal to minus 4, and we have gone through this thing that x is going to be plus or minus 2i. Okay, square root of 4 is 2, square root of minus 1 is an I, and what we get here, let's go graph it. We have 2 minus 2, 2i, and minus 2i. What do these vertices look like? The vertices, of course, these are corners of a square. So if I have a circle here and I start with one of these points, turn it 90 degrees, I get the next one, the next one, and the next one, and then I come back to what I was. So my solutions are 2, 2i, minus 2, and minus 2i if you want to write down the solution. So the solution is very simple. If I locate one of these roots, one of these points, then I'm going to think about a regular n-gon, where n is my exponent, and I simply go from one to the other, and that is what this equation trying to tell us. When it says for k equal to 0, 1, 2, 3, all the way to n minus 1, is simply trying to say that we are going to go over the vertices of that polygon, count all of them. So whatever k is, it's going to give us a corresponding vertex, and that is going to do the problem. Now, problem type 1 is going to refer to situations where the right-hand side is either real or pure imaginary. In the next lecture, it's just going to be mixed, but the formula is going to be the same. So let's go ahead and do the problems here in the style that is required from us, so that we understand that application of the Moivre's formula, if I can pronounce that French scientist name correctly. So we are solving x squared equal to 16, just like we had over there. First, I take 16 and write it in the polar form. Meaning what? Polar form, so you remember if I had z is equal to a plus bi, I want to write it as r times cosine of theta plus I sine theta. So that's the first step. Whatever the right hand side, we are going to write it in that style. So what is the angle of this? The angle is of course 0. Is that right? So this is 16 really times cosine of 0 plus I sine 0. So because I am at angle 0, cosine 0 is 1, sine 0 is 0. So my theta is 0. My R is uh, 16. The formula says what? The formula says take the fourth root of your R. So R, so first of all, N, here's my N. N is 4. So R to power of 1 over N means 16 to power of 1 over 4. Fourth root of 16, well, we need to know this. The fourth root of 16 is just 2. Next, we take theta and divide it by 4. Theta divided by the same 4 that you had here. Let me write theta over n. So 0 divided by 4, of course, is 0. That is for the first vertex. Then, depending if you want in radians or in degrees, pretty much it looks like all these problems are asking you in degrees. If we take 360, divide that also by n. So 360 divided by 4 is going to be 90 degrees. Now we are going to form our roots. The fourth root of r, so I'm going to take 2 times cosine of theta over n. So theta over n, which is 0, plus k times 90. K times 90. Let me write it 90k. It looks better that way. Plus I sine of theta over n plus same 90k. What does 90k means? That's the rotations that we are going to go through. What are the rotations? First one is the first vertex, then the second vertex, third vertex, fourth vertex. By the time we come to 3, we stop. We don't need to go to 4. 4 is going to take us back to where we were. So I will have twice cosine of theta over n turned out to be 0 in our problem, so that's just 0. If this is also 0, so twice cosine of 0 plus I sine of 0, that is a very lengthy way of saying just 2. Okay, this is 1, this is 0. Next, twice cosine of, well, we understood this first one is 0. Next, k is 1. K is 1, this becomes 90 plus I sine of 0 plus 90. Cosine of 90 is 0. Sine of 90 is 1. I get 2i. Then 2 cosine of 0 plus. Now my k is 2. K times 90, it becomes 180 plus I sine of 0 plus 180. Cosine of 180 is minus 1. Sine of 180 is 0. So this is a long way of saying just minus 2. Finally, we have twice cosine of 0 plus what? By now we have reached k equal to 3. 3 times 90, that is 270. Plus I sine of 0 plus 270. Well, cosine of 270 is 0, sine of 270 minus 1, and I get minus 2i. So here are the 4 roots, 2, 2i minus 2 minus 2i. These are the roots that we arrived at here by just plain algebra. Here we got it by applying the Moivre's formula, and we get this answer. Let's go practice one more time. Here x cubed is equal to 8. This time I'm going to be faster, so x cubed is equal to 8. I take this number, take cube root of it. So cube root of 8, of course, that is just 2. Then times cosine of, what is my theta? Theta, in this case, is just 0. That is, if I write 8, how do I write 8? I say 8 is, in the polar, is cosine 0 plus I sine 0. This theta is 0. I take theta divided by 3, that's still 0. Okay, 0 divided by 3, still 0. So 0. Plus I take 360, also divide that by 3. So that's become 120. So I'll have 120k plus I sine of 0 plus 120k. So that is 2 times cosine of, in the first case, k is 0, cosine 0 plus I sine 0. Again, this is a lengthy way of saying just 2. Next root, 2 cosine of. So first case k0. Next case 1. If k is 1, this is cosine of 120. Of course, these are all degrees, all right? Plus I sine of 120. Who is that? 2 times cosine of 120. What's that? Cosine of 120. That's minus a half. Sine of 120. Radical 3 over 2. Simplify, you get minus 1 plus I radical 3. Next and last, k is equal to 2. So we get 2 times cosine of 0 plus 2 times 120. That's 240. Plus I sine of, angle's always the same, 240. Cosine of 240, same, minus a half. Sine of 240, that one is minus radical 3 over 2. Simplify, minus 1 minus I radical 3. Final answer, string them, separate them by commas. 2 minus 1 plus I radical 3 minus 1 minus I radical 3. These are the roots. So if I had x cubed equal to 8, it tells me x is one of these 3 things. Okay, one more example. Similar to what you just had, except the right hand side, we have an imaginary number. Okay, we say problem type 1 here simply means right hand side is either real or it's just imaginary. Just separated these questions aside, even though they're not all that different from everything else. So step 1, whatever right hand side is, write it in polar. If this is I, obviously, or think about it like this. Here's where I is. What angle is involved here? Of course, it's pi over 2. So R is 1 cosine of pi over 2 plus I sine of pi over 2. So whatever the right hand side is, write it in polar. Next, so our theta, our base theta is pi over 2. Cube root of 1 is just 1. So if we go ahead, write 1 times cosine of that base angle pi over 2, and I forgot that, well, need to go back a little bit and correct myself. This everything here is in degrees, so sorry for that. Let me just go ahead and write in degrees. So these were sorry, 90 degrees, 90 degrees, it is 90 degrees, and this one too. This one also, everything is 90 degrees. So we take 360 divided by the exponent of the problem, and multiple of that is going to be added to our base angle, plus I times sine of, same thing, 90 plus 120k. That is what the root is going to be. So the x we are looking is that. So let's write out what is it that we are trying to find. For case 0, so k0, this is cosine of 90 plus I sine of 90. For k equal to 1, x is, add 120 to this. So x is cosine of 210 plus I sine of 210. Finally, k equal to 2, x will be cosine of, so 240 and 90 makes 330. Is that right? 240 and 90, 330 plus I sine of 330. Okay, now let's simplify. The final answer has to be written in standard form, just numbers. Cosine of 90, that is 0. That is I. Next solution. Cosine of 210. 210 is 180 plus 30, so that is going to be minus radical 3 over 2. And sine of 210 is going to be minus 1/2. Third root, x is going to be cosine of 330. 330 is the same as minus 30. That's how I remember them. The radical 3 over 2. Sine of 330 is minus I times 1/2. These are the three roots. So if a right hand side is given, you convert it to polar, take the nth root of r, nth of the angle, nth of 360 degrees, multiply that by all numbers from 0 to n minus 1. That's going to give you all of the roots for the problem. So again, the formula looks a bit intimidating, but it's actually very straightforward. A big story, bigger than this, is that an equation of degree n has n roots. They could be real or complex. If we count all the roots and count their multiplicities, we always have n roots, and that's what we are finding in this problem. Okay, until next time, good luck and God bless.